This video is going to cover the 2.5 warm-up and then the 2.4 and 2.5 quiz review. So let's start by looking at the warm-up. This first question says, find a third-degree polynomial function, f of x, with real coefficients that have 3 and 2i as zeros. So as you're reading this, hopefully you see the words third degree. Okay, a third-degree polynomial means that your answer should be an x to the third. So if you just use the roots that are there, which is 3 and 2i, you'll end up with an x squared. Hopefully that's enough indication to remind you that there are more roots than are just there, and the extra root comes from the complex number. So that if 2i is one of your roots, and that's a complex number obviously, then the conjugate of that, which would be negative 2i, is also a root. So with that, my linear factors would be x minus 3, and then x minus 2i, and x plus 2i. And then I would distribute that out. And you want to start with the ones that involve the i's, because the i's will cancel out if you use the conjugates first. So this is x minus 3, and then distribute the x, obviously, to both. So this would be x squared plus 2ix, and then distribute the negative 2 to both, negative 2i to both, which would be negative 2ix minus 4i squared. So the x minus 3 is still there. The x squared is the only squared term. A positive 2ix and a negative 2ix cancel out. This I squared becomes a negative 1. Negative 4 times negative 1 is a positive 4. And then you just have to FOIL these out. So the first would be x to the third, outer 4x, inner negative 3x squared, and last negative 12. And then you just want to rewrite that in decreasing degree format. And because we're looking for a function, I set this equal to f of x. Okay, then I want to look at number 2. So number 2 says, what are the zeros of the function f of x equals x to the third minus 11x plus 50? So because I'm not given any information about any of the zeros here, I know I have to start with my possible roots. This is clearly not factorable. It's an x to the third, and there's only 3 terms, so I can't factor by grouping, and I can't use the quadratic. So this is where I build my bank of possible roots. So my possible factors are plus and minus the last over the first. The first is just 1 because whatever's in front of that x squared is just 1. That 150 means we're going to have a big amount of factors. So I know that there's 1 and 150. I know it's 2 and 75. I would see if 3 goes into it. So the trick there is add up your digits. See if they add up to 3. 1 plus 5 is 6. That is divisible by 3. So 3 goes in 50 times. See if 4 goes in, so 150 divided by 4 does not go in evenly, so then I go to 5, and it would be 30. Try 6, so 6 into 150 would mean 6 goes into 15 once, with 3 left over. 6 goes into 30 5 times, so 6 does go into there. It's 25. Think about it in terms of quarters, right? 150 is not divisible by 7. It's not divisible by 8. It's not divisible by 9. The next one would be 10 and 15. It's not divisible by 11. And then 150 divided by 12, again, doesn't go in evenly. 150 divided by 13 doesn't work, nor 14, and we're wrapped around back to that 15. That would be the factors of 150. Since the first term is just that 1, that means that my possible roots are 1, 2, 3, 5, 6, 10, 15, 25, 30, 50, 75, and 150. And now we start to test our possible roots. So I'll start with 1 on the outside. When you look at the order of your terms here, you're missing the x squared term, so I make sure that that's 0x squared. So this would be 1, this would be 0, this would be negative 11 and 150. And I start trying. So 1, 1, 1, 1, negative 10, negative 10. So these numbers are small. If you want to keep trying, you can. But hopefully you realize that with numbers that are small like that, we're going to have bigger jumps. So let's just say I skipped a 5. Okay, I'm still not big enough, so let me try 6. So I have 150, it's just the wrong sign, which means I'm going to try -6 on the outside. And there's my 0. So -6 is the first 0 of the function. And then I need to take my reduced polynomial, which is x squared minus 6x plus 25, and see if I can factor it. There are no factors of 25 that sum to -6, which means that this is now quadratic formula. So my A is 1, my B is -6, and C is 25. Formula is the opposite of B, so this will become a positive 6 plus and minus the square root of B squared, so -6 squared, minus 4 times 1 times C, which is 25, all over 2 times A. So I get 6 plus and minus the square root of 36 minus 100 over 2. 6 plus and minus the square root of -64 over 2, which is 6 plus and minus 8i all over 2, or 3 plus 4i, because 2 goes into both 6 and 8. So this is 3 plus 4i and 3 minus 4i. Those would be your additional 2 roots. So I've got 6, 3 plus 4i, and 3 minus 4i. So roots or zeros or solutions would be listed out like that. If it had asked for the product of linear factors, then I put each of those behind the x minus. So if it did not say this, but let's say that it had said list them as linear factors or product of linear factors, then it would be x plus 6, I would change the signs, x minus 3 minus 4i because the negative goes to both, x minus 3 plus 4i because the negative goes to both. So this would be listed as a product of linear factors. All right, so now let's talk 2.4 and 2.5 quiz review. So from 2.4, this was our reintroduction to complex numbers. We talked about adding, subtracting, multiplying, and dividing the complex numbers and how to identify the conjugate. And we talked about what would be standard form. So when we add, subtract, multiply, and divide those complex numbers, and it says to put it in standard form, or even if it doesn't say it, it's implied standard form, you always want your answers in that A plus BI format. So if my solution was like -6i plus 3, I would switch it around so that it's 3 minus 6i. So the I is always the last thing that you write. So I'm going to just do an example of probably the trickiest part of those, which is the quotient. So if I had 3 minus 4i over 4 minus 5i, that I is an irrational number. It can't be left in the bottom. So we multiply both the top and the bottom of this fraction by the conjugate of the bottom. So even if this is negative, okay, if the 4 is negative, the 4 is positive, it doesn't matter. What you're looking at is the sign in between, or the sign that's on the I value. If that's a negative, then I switch it so that this becomes 4 plus 5i. And then I multiply that in the top as well. So first I'll distribute out the numerator. 3 times 4 is 12. 3 times 5i is 15i. 4i times 4, negative 16i, and negative 4i times positive 5i, negative 20i squared. So then I can combine like terms and change this I squared to a -1, making this a positive 20. So now I've got 12 plus 20, which is 32, and 15i minus 16i, which is negative I. That's my numerator. And then in the denominator, you have choices. You can either take that and FOIL it out and do that work, first, outer, inner, last, or you can use the shortcut, which is a squared plus b squared. The a being the real part of your complex number, which is the 4, and the b being what's in front of the I. So it doesn't matter if it's positive or negative because we're squared. So we say 5 squared. So this is 16 plus 25, which is 41, and that goes in my denominator. If either part of this fraction can be reduced, so if I can split it, this would be 1 over 41i. If either of these parts can be reduced, then you have to split it. If not, I'll take either answer. So you can leave your answer like this, or you can split it. If it was a multiple choice, so by the time your test rolls around, you'll start to see the i's split up and the term split up and the I kicked to the outside like the bottom one. Also in 2-4 was your quadratic formula, so just make sure you know it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't confuse your signs. A lot of people do that, silly mistakes. Sometimes you'll get real numbers underneath the square root. Sometimes you'll get a perfect square. Sometimes you'll get a complex number, okay? Just know that you can plug it in and then simplify it as best you can. 2-5 was now finding the possibles and then using those to find the actuals and solving the reduced polynomial. So this is if they give you no terms, it's not factorable, you can't use the quadratic, then you'll do something like this. The quiz instructions will actually tell you to find the possible roots, which is plus and minus the last over the first. So the factors of the last number over the factors of the first number. And then take those and use synthetic division on the outside, changing out those roots until you get to one that has a remainder of 0. Once you do that, you know that's a root. If you've reduced it enough that it's either factorable or you can use the quadratic on it, then you can solve it. Also in 2-5 was writing the function given the roots. So if you're given, when we did this in 2-2, we were given real numbers like 3 and negative 2, and you would put those behind x. But now you're going to be given something like negative 2i and 3. Remember, these complex numbers come in pairs, so if you have a negative 2i, you immediately know you have a positive 2i. And then you would write x minus 3, x plus 2i, and x minus 2i. And then you would multiply those out, and at the very end, make sure that you put f of x as it's what it equals. And then the last type of problem in 2-5 is if you're given one imaginary root. So if they give you the function f of x equals, which you'll see in a minute, and they give you one imaginary root is 5i, then we know the other imaginary root is negative 5i. We put those behind x. We FOIL that out, and then we divide using long division, that on the outside as the divisor, and then the initial function as the dividend. Let's work out that example. So it says, given that 2 minus 3i is a root of x to the third minus 9x squared plus 33x minus 65 equals f of x. Find the remaining roots. So if 2 minus 3i is a root, then we also know that 2 plus 3i is a root. So we already have 2 of my 3, and I know there's 3 because the highest exponent is to the third. So I'm going to do x minus each of these, x minus 2 plus 3i, and x minus 2 minus 3i. Distribute that negative, so x minus 2 minus 3i, x minus 2 plus 3i. And then I'm going to multiply this out. So this is where you want to be really careful. Again, I'll pull out the colored pencil so you can kind of color code this, but this is a lot of steps. X times x is x squared. X times negative 2 is negative 2x. X times 3i is 3ix. Then move to the next one. Negative 2 times x. Negative 2 times negative 2. Negative 2 times 3i, negative 6i. And the last one, negative 3i times x. Negative 3i times negative 2 is positive 6i. And the last one is negative 3i times negative 3i, which is negative 9i squared. Okay, so now I want to go through and make sure my i's cancel out, because if I've done it right, they should. I have a positive 3ix and a negative 3ix, and then a negative 6i and a positive 6i. So they do. And then the I squared becomes a negative 1. This negative 9 becomes a positive 9. And then combine your like terms. So I've got x squared. I've got 2 minus 2x's, which means negative 4x. And I've got a positive 4 and a positive 9, which means positive 13. So that is a factor of my initial function, which means I can now put that on the outside. So I'm going to use long division. I'm going to do x to the second minus 4x plus 13 divided by my initial function, or divided into, sorry, my initial function. Make sure it's in order of decreasing degree, which it is, and make sure there's no terms missing, which there are not this time. And then we're going to divide this out. So I'd have to multiply x squared by x to get to x to the third. I'm going to multiply it times all three terms on the outside. I get x to the third minus 4x squared plus 13x. Change your signs. This cancels. This is negative 5x squared. This is positive 20x. And I bring down the negative 65. And then I have to multiply x by negative 5. X squared by negative 5 to get to negative 5x squared. Multiply that by all three on the outside. I get negative 5x squared, positive 20x, negative 65. Change your signs and add, cancels, cancels, cancels just like it should. If it doesn't give you a remainder of 0, then again, you know you did something wrong. Okay, so now we've got our last factor, which is that x minus 5. And from there, you would know that your remaining root would be positive 5. So if it wants you to just give the roots, I would solve that x minus 5 setting it equal to 0 and then list it with the original root and its complex conjugate. If it asks for you to write it as a product of linear factors, that's where it would go behind the x. So I would get x minus 2 minus 3i, x minus 2 plus 3i, and then x minus 5. So again, this would be for roots, solutions, zeros. That would be the terminology there. And this would be for a product of linear factors. All right, so the rest of the material is on your quiz review. Hopefully the stuff that's on there you can do well. If not, then spend some time preparing for it. Your solutions for the 2.4 part are on the initial quiz review, and then the 2.5 are separated off and worked out.
Good luck on your quiz!